let's continue then. We're now actually going to see some real code, and is even going to be Ruby. I know we saw a lot of different kinds of code. We saw a lot of different code examples here. There were, for instance, SQL, but yeah, now we get some actual Ruby. And I wrote a gem called composable operations, which basically is an implementation of the transaction script. But it is also more than that. And you might ask, why not call it transaction script? And that is because when I started working on this project, we just internally called all of our business processes operations. And that is why I chose the name. And it is really only another word for transaction. And some people like to call these things services. Some call them interactors. It's all the same, basically. Operations provide more features than common business transactions. They can be combined into an operation pipeline. If you have a really complex business process, you can split up into individual parts. Then it comes in handy if you can have multiple operations combined to a higher level operation that models the entire business process. This way you can reuse individual parts of operation pipelines to form other pipelines. A pipeline itself is also an operation, meaning everywhere you use an operation, you can also use a pipeline, and you can go crazy and actually build pipelines that contain pipelines if you have really the need for it and model complex business processes. Okay, finally, code. So, this is an operation for CSV export. It's something, it is not very complicated, but exporting data is something we all have to deal with, and there are probably 100 ways you can export CSV from Rails applications. I chose to implement it as an operation, and the thing about operations, there are 3 important parts. We will cover them in a bit, but just to give you a quick introduction, there is, you need to specify the kind of data you are processing that is done by the call to processes, and then you can provide configuration options, and in this case, we provide a set of attributes we like to export. And then the third thing you need to do is implement the execute method, which is the algorithmic core of your operation. And in this case, it's a very simple one. Why do I still like to keep something as simple as that in an entire class? Mostly because now I have scope. I can extract certain parts of the operation's core logic, like the conversion of the records into CSV data, into own methods, and they don't mess up any components where this code actually shouldn't belong. So this is why I always pull my code into an entire class. Just for the sake of completeness, here's how I convert records. I basically iterate for each record. I iterate over over all the attributes, and then call the getter for this attribute on the record. So, I briefly mentioned processes. Processes just generates a bunch of getter and setter methods for you that allow you to conveniently access the data that is being processed by your operation. So we have, in the first example, we have the operation processes one element, and this element is an array of records. But for instance, we could model an operation for adding a user to a group, and in this case, it makes sense that the operation gets initialized with a user and a group. So you can basically define an arbitrary number of arguments your operation is going to process. Then you might have noticed the call to property. As I said, the calls to property are usually used to configure configuration options in that sense. And properties are just smarter getters and setters, because properties allow you to define default values, to flag certain properties as required, or to do conversion when values get assigned, and finally validate the input that is provided to a property. If you like properties and don't want to use composable operations, I extracted that part out. It's a really small gem. It just helps you to build smarter Ruby attribute assessors faster. Then there's the algorithmic core, and the operation you see here is a perfectly valid operation because the only thing you truly need to implement for something to be in operation is the execute method. So let's put that operation to work and export some CSV. So there are two ways you can do it. You can either initialize the operation and provide all the important data to the operations constructor, so the records that need to be processed as well as the attributes you want to export. And then you call perform on this operation instance, and as a result you will get CSV back. There's also a more convenient way to do it. You can simply call the class method on your operation and provide it with all the data you would provide to the constructor. Maybe you've noticed you implement execute, but you call perform. Why is that? The thing is, operations have state and provide advanced control flow mechanisms, as we will see soon. And perform basically controls the flow of your operation. An operation can have 4 different states. It can either be not executed yet, or once it was executed, it can either be in the state succeeded, halted, or failed. If you don't halt or fail during your operation execution, the operation is automatically going to be in the state succeeded. If you want to break at some point because something went wrong in your operation, you can simply call fail, which has the same interface as the raise method. So you can specify the type of exception you want to throw. You can provide a message, and you can also provide a stack trace if you want to. As I said, there are more advanced control flow mechanisms. Every operation can also have before and after filter that get executed before or after the algorithmic core of your operation. You can have an arbitrary number of these before filters, and all the mechanisms like halting or failing an operation will work in these blocks as well. So here's an extension to our CSV export just to show you how these before blocks work. In this case, we just want to make our operation a little safer. It is not really part of the algorithmic core. And this is why I pulled it out into a before filter, because all we do is we make sure that records is actually an array, and then we iterate over all of our records and check if they implement the necessary interface, that is, if they respond to all the getters you specified in the attributes configuration option. If there's a broken record, then we fail with an argument error. You can, of course, make this more informative by providing the user with information on which record precisely it is that failed, but this is just a simple example. So now when we invoke our operation and end up in a state where it fails, it will actually throw an argument error. This is only true if we use the class method. If we instantiate the operation, then no exception will be thrown, because I assume that you have the operation instance around, and then you can just question the operation, whether it succeeded or failed. Besides, in order to compose operations into pipeline, this was a necessary design step I had to take, as we will see. Right now, our operation is very inflexible, and I thought I just want to give you an example for another design pattern that isn't even hard to implement, but can basically make your operation a lot more flexible. And that is if you allow records to be decorated before they are converted into CSV. Now we simply add another property that is a decorator, so an object that wraps another object. And again, for the sake of completeness, the decorate method. And it's very easy. We just check if a decorator has been provided. In this case, we wrap our object, and if not, then we just return the record itself. But is CSV export a true business transaction? It's not. And, but I think it's still a good example on how to use operations. The thing is, no customer will tell you, I need CSV export, because he will tell you what kind of data he wants to have exported. So he will probably tell you that that he wants a list of users or a list of messages posted or something, and this will be his business requirement. But there's nothing wrong to building more generalized components that you can actually use to solve multiple needs at the same time. Because if you want CSV for users, there might be a time coming where you want some other data exported as well. So now to the more advanced usage of composable operations that actually make for the name composable, and that is about combining operation. And that is handy if you model more complex business processes. I stick to, and in software development, we speak of a processing pipeline if we have a set of software components that are connected in series, and the output of one component is the input of the next one. So, composable operations allow you to define such a pipeline in a very simple fashion. There's a macro method called use. It's best to just look at the code example. And in this case, we define a pipeline named sum pipeline, which consists of an operation A and B. And if I call perform on the pipeline, then operation A gets executed, and then the result of operation A gets forwarded into operation B, and some pipeline will then finally return the result of operation B. And this is where the failing and halting mechanism comes into play, because some pipeline will also fail if one of its sub-operation fails. Meaning if you check the correctness of data in operation A and decide that the input is invalid and fail with an argument error, for instance, then some pipeline will fail with this argument error and take care that the stack trace is correctly laid out for you so you can actually find the error more quickly. So this is more, again, a toy example. There will be a real one in a moment. Let's say we have an operation that allows us to fetch random users from the database. Doesn't make so much sense, but and then we can export these users into CSV. What I actually try to show here is that you can separate the data obtaining part from the data processing part. And you could simply use, you can reuse CSV export in multiple operations, and yet you can assemble highly specific operations to model certain business transactions. There's one important thing. We have seen that we can configure operations using properties, and the thing is, we also need to be able to configure our operation pipeline. So the way it is built right now, when the pipeline gets instantiated, it allows you to provide options to individual components during runtime. And this is by specifying a lambda statement to the keyboard arguments of the use method. So in this case, the moment the operation gets initialized, it will check what limit has been specified to the wrapping operation. So maybe you decided to call export random users with a limit of 100. Then this limit will be forwarded to the operation that takes care of the data fetching part. Now I'm going to present a real-world example. If you need to export CSV data, it's very likely you need to import CSV data at some point as well. Our CSV is very simple. We have 3 columns: name, family name, and age. But the thing is, our user model looks different internally. We have different field names. Internally, we call the name column first name and the family name last name. And there are additional fields that are not provided by our customer. So we may want to generate a password when importing the user data, and so on. So what we really need to do to model this business process is we need to parse the data, then potentially sanitize the input to make it easier to work with. Then we map columns. Finally, we generate additional columns, for instance, the password that isn't in the CSV. And the last step is to create user records. And that actually is a very linear process and therefore can be modeled with a composable operation. So in the middle, you see the 5 components, basically, that correspond to the business needs I just presented. And this operation takes a set of mappings and generators that allow to configure the operation without subclassing or anything. And while we are at it and talking about properties, I just want to point out one additional feature of properties. Properties are actually defined in an anonymous module that gets injected into the inheritance chain of your operation, allowing you to simply override the method and giving you the possibility of calling super to take advantage of what smart properties generated for you. So in this case, we just merge in a generator for generating random passwords. Let's take a look at the individual operations. The CSV parser is super simple because it just wraps the CSV standard library. And what it will return once it is executed is a lazy enumerator for records. The next step is input sanitization. And all I do here, it looks a little fancy, but all I do is symbolize the hash. I wrote the example code outside of a Rails application. This is why I don't just use active support symbolized keys. But as I said, the input sanitization could also be much more complex. Then it would result in a bigger operation. So now we're certain that the next operation gets called with a proper hash. And what we now do is we map the external columns to our field names. And this is simply done by providing the operation with a set of instructions that is just a hash where the key points to a value and the key is the name of the column and the value is the name of the field that should be mapped to. So basically, we rearrange our hash according to the instructions. Once that is done, we forward this data that is now correctly mapped out into the next operation that allows us to generate data. Again, there is a set of instructions, and these instructions can either be strings that contain formatting options, or it can be lambda statements that will be called and receive the record. So you can basically do arbitrary things you can basically do arbitrary content generation at that time. Once that is done, the records get finally forwarded to our user creation operation and instantiated and possibly stored at some point in the database. Now our requirements change, or our application grows, we get new customers, and suddenly these customers don't want to use CSV, but they rather provide us with JSON and also different data. In this case, we actually get the email address. We could basically write a JSON import operation, but there's only one line difference. So for me, this is still a lot of code duplication. Even though we now reuse all our individual operations, it seems too much to just change one line and implement an entire class, which is basically a copy of the other one. So it would be nice if we could choose our data source or parser at runtime. What we need is a placeholder. And there is, again, a software design pattern for implementing placeholder, and these are usually called proxies. So what we need is an operation that can be used as a placeholder for another operation. And all this one has to do is it has to instantiate the real operation and provide it with all the input, and then basically perform it, and finally copy the state of this operation onto itself, because the proxy needs to forward the state informations to the composing operation. This allows us to pull all the code into one single class, call it import, and now our first element in this pipeline is an operation placeholder, and the correct operation is chosen at runtime. And you can simply do this by calling import perform and provide the parser you want to use as an argument. On top of that, you can now simply provide convenience methods. So you end up with something that is called import CSV or import JSON, which instantiate a pre-configured operation pipeline. And that is really what I'm aiming at. One line of code that basically executes an entire business transaction. So, and putting these code into your controllers makes them very slim without cluttering your models with code that may not belong in the model layer. And yeah, that's basically what I just said. I just forget to get to the next slide. It's about grouping code. Also, operations provide you with a unified interface. All operations have the perform method, and you have the positional arguments that are your data sets that are processed, and then you have the configuration options you can specify. And this makes them independent of and this makes the interface independent of the underlying business process. So you just know there's an operation which is called create user or delete user. You know it is going to have the same interface as any other operation, and as it is called delete user, the first positional argument is very likely to be a user. So again, you can basically code by assumption, just use it and see if it works, without actually having to open up the code and see how the interface is designed. Also, as we just saw, the flexible composition mechanisms help you to reuse more code. And that ultimately helps you to understand your code base better, because now you have a clear structure on how to model your business transactions, and all business transactions are built the same way. And this is where I want to completely shift focus, because you probably noticed that I actually have to give 2 talks. But since the second one was also a lot about software design, just a completely different aspect in the Rails environment, I decided I combine the introductory part and have 2 two example scenarios I present at the end. The first one we just covered, how to model business transactions, and now we will take a look at how to clean up our view logic. And there's a gem I wrote. It is a really super tiny one. It's about 50 lines of code, because the concept I'm going to present to you is what is important. The implementation is super easy. You can basically do this yourself if you want to. Views are sadly the most neglected part in any Rails applications. And we seem not to care so much about code duplication. If you have to write 3 lines of HTML over and over to basically define the same interface component, that's still okay, 3 lines of code. That doesn't feel wrong. But in larger Rails applications, which have constantly to deal with change and growth, we actually have to deal with the problem, because even these 3 lines of code can be really nasty if they are all across your project, and suddenly you need to change all these components. There's a more severe problem, though, and that is that Rails doesn't separate concept from representation. Conceptually, a button will always be a button. It is something that you can click, and it will trigger an action. But the representation, looking especially at iOS 7, for instance, can completely change. They changed the buttons from being round and in a skeuomorphic design to something that is flat, or even something that is only a link. But conceptually, it's still a button. So when you build your application, you still use buttons. They just look different now. And separating concept of an interface component from its representation is something that is completely normal for desktop applications. And we do this because nobody wants to write C drawing code just to get a button on the user interface. So all this drawing logic, and therefore the representation logic, is nicely hidden away. We can use this concept for web applications as well. The thing about HTML is it's much easier to write than C code, especially C drawing code, but it is still a very repetitive task. And you can't simply change the representation of an interface component if you don't separate it out the concept. Also, if you use interface components, you can model them in a way that they enforce constraints. I certainly made a lot of mistakes when writing Vue code, misspelling class names, using the wrong class name. At some point, I just ended up browsing the CSS code and seeing how the class was actually spelled. Widgets can take care of that for you. If you model them in a way that you can't misuse them as developers, and they basically scream by raising an exception when you misuse them, you get imminent feedback. And also, modeling widgets as Ruby classes allows you to use inheritance mechanisms and all these standard software design principles that can be used to clean up the code that make up a widget. So let's finally see how a widget looks like. It simply inherits from action widget, and again, it uses smart properties internally, and this might be overkill. Some people might think this might be overkill to use an entire class just to render 3 HTML elements. The thing is, this widget was born at some point in the lifetime of the application I was working on, because we are recurringly using panels all around in our views. And then at some point, our SEO guy came to me and asked me, would it be possible to change all the headlines of all sidebar panels that are across these hundreds of thousands of different views because an H3 would make Google parse the content better or something like that. So basically, he told me this would positively influence the ranking that Google does. And he knew that doing things like changing all the headlines in all the views in the entire application, that this is a painful task, it is very repetitive, and it is something nobody wants to do. Having, however, a widget that represents the concept of a panel and implements its drawing logic makes things certainly easier, because now wherever we use panels, we simply instantiate a panel widget in the view, and now if a request comes in to change something about the panel, it's mostly about its representation, then we simply go to the panel widget code and alter it. In this case, it was a change of 20 seconds. I just simply had to switch out the H2 with an H3. So we saw how to define a widget. Now, how can we use them? We can use them anywhere in our Rails views. And for every widget, there will be a corresponding helper method. And what this helper method does, it simply instantiates the widget, provides the widget with the view context, so the action view instance, and passes on all the configuration options. And there's also an example for manual invocation, where you simply instantiate the class and provide the view context. And providing the view context is necessary so you can use all helper methods that are available in the controller context inside your widget. And widgets are utilizing the delegate patterns, so they implicitly delegate all methods that they don't know or implement themselves to the view context. But you can also always explicitly call methods on the view context. Again, they use smart properties which allow you to do auto-conversion, validation, default values. And this comes in really handy when you model widgets, because it is easy to just miss out some HTML and maybe misspell a class name. But if you define a property, for instance, for the panel that it has to have a title, then the widget will just tell you, if you don't provide it with a title, it will raise an argument error telling you that you just misused the component. And the only thing you need to implement in order for widget to be recognized as such is the random method. And if you want to have these automatically generated helper methods, you need to suffix your widget with the word widget. Otherwise, the class lookup will just not work. I said widgets are good for reusability. So far, we haven't seen any of that. But now that we are inside a Ruby class, we can actually extract code into certain we can extract certain parts of the code into their own methods. And then we can simply inherit from our widget and, for instance, build a special type of panel that maybe has an icon in the header or something like that. To wrap it up, what are the benefits compared to partials? Partials don't allow you to enforce constraints and do auto-conversion of configuration options. It is really handy to get immediate feedback and know that you missed to provide required configuration options. A partial will not tell you. Maybe if you're lucky, you will get a null error telling you that, or basically an error that the method is not defined because you missed out to provide certain variables to the partial. But an interface component can really do much more. For instance, it can take care for generating CSS class names the way you use them in your project. For instance, we have a button widget which accepts an icon as a property, and I can never remember if these icons are prefixed with the word icon, if the names are with dashes or underscores, or if they were actually suffixed. You can basically build a type property that when an icon property that when an icon is provided, it takes care of generating the correct class name that is then attached to your HTML. We already talked about reusability, so I will just skip that. Again, we have a very unified interface. There are these automatically provided render methods. There are these automatically provided helper methods, and every widget just has to implement a render and can get a set of properties. And for me, the most important part is actually the imminent feedback, because I want to know if I misuse a widget, and the other important part is that I can easily change the representation without altering the concept of a component. There will be one more example, and this example is slightly more advanced because you can nest widgets, and this is actually the code that precisely makes up this slide, because this slide is web-based, and I have a slideshow widget, and this slideshow widget can be provided to the helper method. And what this widget does, it provides convenience methods that generate slides for you. So in this case, I instantiate the slideshow widget, and then I can simply call slide and provide a title and a subtitle, and this slide appears on screen. This is how it looks internally. The slideshow widget simply provides a container called slides, and then it uses capture and provides itself to the block you define in your view code. And a call to slide itself uses another widget called slide widget and forwards the arguments. And you can also have your slides. Again, have convenience method you use when building up your slideshow. And then you can maybe have a third method that basically builds another type of slides. As you probably noticed, there are two types of slides in my slide deck. There are these white ones with lots of code, and the blue ones. The blue ones I just call stage, and what they basically do, they take care of centering the content on the slide. And so I just provided my slideshow widget with a convenience method that instantiates a new slide, then automatically wraps everything in an inner div and centers this on screen. So with these 3 lines of code, I get basically down to the HTML down there. And if I ever want to change the representation, because I maybe use a different CSS or a different JavaScript framework, conceptually, the slideshow will always be a slideshow, but the representation might be completely different. And that's about it. We talked about obstacles we have to face in software development that are change and growth. And then I showed you 2 examples on how to improve 2 aspects of Rails that are not covered by the framework itself, that is business logic and how to clean up your views. All the code you've seen, or all the gems are available on GitHub, and you can find me on Twitter or GitHub by @t16. Thank you very much.